My beautiful family, how are you doing? That's a good day to you all. You are welcome again to my YouTube channel, Mathematics Made Easy. That's the place we solve problems with ease, with ease, without any problem, without giving ourselves problem. We solve problem with ease. All right. So you are welcome again to my channel, Mathematics Made Easy. In today's video, we'll be deviating from calculus. So we'll be moving into a little bit abstract algebra, and then this is modular arithmetic. You are going to need this modular arithmetic wherever level you are. Maybe you are still in secondary school, you are in college, mathematics department, or anywhere, or you are doing abstract algebra. You are going to need modular arithmetic very well. Okay. It's not something that is hard, very easy to solve. Yeah, very easy to solve. But the method I will be using for today, it will be somehow different from the method you have been taught in your secondary school or in your calculus. I mean your institute. So I'll be using a very unique method and then very straightforward and easy. So stay tuned and then make sure you watch the video to the end so that you can gain something from the video. All right, so before I dive in, please, very necessary that your subscription is very important. Please don't forget to subscribe to my channel. That's how you help me to encourage me to upload more videos. So your subscription is very important. Help me to subscribe to the channel. Help me to share my videos to your friends so that they can also learn, they can also gain from what I'm teaching. Like my videos so that you can encourage me. Okay, maybe whether you like it or not. Okay, this video is interesting, so help me to like my videos and comment what you think about the video and share. Thanks. All right, so let's dive into the solution of the problem. I would like to use what we call the floor function. Okay, so that's what I'm using to solve this problem. Floor function. Floor function. All right, and then this is the floor function of x. So we can assume that, okay, this is a definition. K is less than or equal to the floor function of x, and then less than k plus 1. A value after k, that will be k plus 1. So where k is an integer, don't forget. So k is an integer. If you draw the graph of your floor function, whenever it reach an integer, it's going to deviate from the graph. It's going to deviate from the graph. Okay, but we are not into that so much for today. Okay, guys, let me give you an example here. You want to find the floor function of pi. So what will be the floor function of pi? The approximated value of pi is 3.142. So I can say pi is 3.142. Okay. So what will be the floor function of 3.142? That will be 3. Okay. The value before the point. Okay. The value before the point, that will be the what? The floor function. That will be the answer. If I ask you what is the floor function of 0.5, so the floor function of 0.5 is 0. If I ask you what the floor function of 1.5, the floor function of 1.5, that is 1. If I ask you what is the floor function of E, your Euler constant, that would be 2. So that is what I'm talking about. So the floor function. Okay, you can see the very easy stuff, since you already know how to find the floor function of a decimal, a number. Okay, if I ask you what is the floor function of 2, floor function of 2 is still 2. Okay, so since we already know how to find the floor function of decimal number, whole number, so we can now solve the problem. Then how are we going to do that? That is what you're supposed to ask me. But don't worry, that's why you are here. You have to learn. All right. So here is what we are going to use. It's like a definition or formula. So we have x mod y, x mod y. So x mod y is equal to x minus y multiplied by the floor function of x over y. You can see this is very beautiful. Very beautiful definition. Very beautiful. All right, so let's start with the first question. According to the question, according to the definition, x mod y is equal to x minus y multiplied by the floor function of x over y. Don't forget that. So the first question, which is 9 mod 6. So how do we find 9 mod 6? You see here, your x is 9 and your y is 6. So that will be 9 minus 6 multiplied by the floor function of 9 over 6. Okay, so what will be the floor function of 9 over 6? If you find 9 over 6 in decimal form, so that should be 1 point something. Okay, because we can only see 6 just once in 9, it will remain 3. So that will be 1. So the floor function of 9 over 6, that is 1. So we are going to have 9 minus 6 multiplied by 1. So that will be equal to 6 times 1, that's 6. That will be 9 minus 6, which is equal to 3. Very simple and straightforward. So floor function of 9 mod 6, that will be 3. And if you solve this normally, 9 mod 6, okay, how many 6 can we see in 9? That is 1, remainder 3. So the remainder, that is your answer, which is 3. So we have 3 as our answer. The second question I gave, which is 8 mod 9. 8 mod 9. So what will be 8 mod 9? So here your x is 8, so that will be 8 minus, and your y is 9. So 8 minus 9 multiplied by the floor function of 8 over 9. So 8 over 9 will be 0 point something, 0 point something. So this will be equal to, and if you find the floor function, that should be 0. That will be 8 minus 9 multiplied by 0. So this will be 8 minus 0, which is equal to 8. Very beautiful. And last question I gave, which is 7 mod 10. 7 mod 10. So 7 mod 10, your x is 7, so that will be 7 minus 10 multiplied by the floor function of 7 over 10. So don't forget, 7 over 10, that will be 0 0.7. And if you find the floor function of 0 0.7, that's 0. So we are going to have 7 minus 0, which is equal to 7. So the floor function, the answer to this question, 7 mod 10, that's 7. All right, guys, you've seen the beautiful method I'm talking about. So don't forget to subscribe to my channel, like my video, and share. Thank you. So see you in the next video.